experiments to organize. You have to get thousands of people tested, and so on. And it was clear that it was not going to give instant, clear-cut results. So that's one test. There's a whole variety of other tests that have been run for morphic resonance, and what you did just now was one of them. It was discovered by none other than Gary Schwartz, who we heard about earlier, in the 1980s. One of his first types of unconventional research was morphic resonance. And when he was a professor at Yale, he did some fascinating morphic resonance tests involving Hebrew words written in Hebrew. And he found that people who didn't know Hebrew could actually unconsciously recognize real Hebrew words compared with false words, anagrams of real words. The point being this: when you read, you don't read a word by spelling out, like a 6-year-old, the different letters. You don't read cat by spelling out k, a, t. You see the whole word as a pattern. It's a gestalt, a pattern, a form. And you've seen it millions of times, and so have lots of other people. And there's a kind of morphic field for recognizing these words. Schwartz's argument was, this should make real words easier to recognize, even for people who don't know the language, than false words, because so many people have seen that pattern before. An anagram contains exactly the same letters, like TCA, it's the same letters as cat, but it doesn't mean anything and wouldn't have been recognized by millions of people. People have done this kind of experiment with versions of it, with Persian words, with Arabic words, with Japanese hiragana words, and they've all given significant positive results. What I'm doing now is trying to extend that line of research using Greek words, and the experiment you did just now involved real and false Greek words. Of the 8 Greek words you saw, to start with, 4 were real Greek words, and 4 were anagrams of words. The question is, when you then came to try and remember them, would you be able to remember the words more easily in the case of the real words than the false words, even though you didn't know that some were real and false? Now, I've done this test several times already, and in most of the experiments, but not all, the real words were indeed significantly easier for people to recognize. That's why I'm trying to replicate it with a completely new set of Greek words. This experiment has never been done before with these particular words. It'll take a while for my assistant to mark these hundreds of papers, so this is not an instant result. But if this is a promising line of research, it would be very easy to put this on the internet. You could see the words for 10 seconds, the answer sheet could come up, you could just click on them, the whole thing could be automatically scored. It would be very easy to automate this kind of experiment. Well, there are various ways in which one can test for morphic resonance in chemistry, in physics, in biology, in psychology, in collective memory. I've just touched on a few of them. You can read about this kind of research in my books, A New Science of Life and The Presence of the Past. What I want to do now is to move on to talk about the extended mind. And I'm not going to talk about all aspects of the extended mind, there won't be time for that, but I'm going to talk about the way that our minds are extended out, or at least our whole being is extended out as members of social groups. All social organisms form groups by definition, and the groups have to be coordinated. This is just to remind you the nature of morphic fields. These could be organisms like people or birds, and then the higher level of organization is the social group, like a flock of birds or a human family or a football team, a social group in which the different parts are coordinated together to work as a group. And this is the nature of social organisms. And I'm suggesting that social organization depends on morphic fields. Here you see a flock of birds over Brighton West Pier. These are starlings, and they form these spectacular groups. And films of flocks of this kind, when slowed down, have shown that when they can all change direction at the same time, they're not following a leader. There's what's called a maneuver wave moves through the flock. And the best computed models of this are as field phenomena. They seem to act like a field, a bit like iron filings moving when you move a magnet over them. The individual birds are responding to the field of the group. And here we see a variety of formations. These are all a starling flock. It shows you something of the amazing variety of forms and shapes these flocks can take up. The maneuver wave can start anywhere in the flock. They're not doing it by looking at a leader. It can start even from the back of the flock. It's not even done by just vision, looking. They're not always looking over their shoulders to see if birds behind them are moving. And the speed at which they move through the flock is far too fast for them to respond by looking at neighbours. So this is a kind of field phenomenon. And we see a very similar thing with schools of fish. And here this remarkable school of fish, they're swimming in this direction, is moving, you see, like a single organism. All social groups have fields, I think, which coordinate their activities. And if we look at if we think about this, it's very often the case that animals split up, social groups split up. For example, in wolves, the adult wolves go hunting, leaving the cubs behind in the den with a babysitter. And they go hunting over hundreds of miles in the Canadian North, for example. It's not when they've gone away from the young that they've forgotten about them or the social group's been dissolved. It hasn't. The social group has stretched. The field joining them is like an elastic band. It stretches and continues to connect them at a distance. And I think that social field, linking the members at a distance, is the basis for connection between them at a distance, which we call telepathy. Telepathy means distant feeling. Tele, as in television. Distant, pathy, as in empathy, feeling. So I think that the coordination of animal groups, including at a distance, as well as when they're close together, depends on morphic fields, and it enables them to keep in touch at a distance. There's good evidence from naturalists' observations of wolves that they are in a kind of telepathic contact with others. And I think this is true of many animal species. It's been very little studied by biologists, but I think telepathy is a normal, natural means of animal communication. It's normal, not paranormal, natural, not supernatural. It's a normal form of communication between members of animal groups. And I think most animals are much better at it than most people. So I don't think it's especially a human thing at all. It's a normal, natural, biological phenomenon. It's very analogous to something Lynn talked about earlier, namely quantum entanglement. If two particles have been part of the same system and then they move apart, they remain connected with each other through what's called quantum non-locality or quantum entanglement. So a change in this one instantly affects the other. When Einstein first realized quantum theory predicted that, he said quantum theory must be wrong, because if it's true, it would allow for what he called a spooky action at a distance. Experiments have shown Einstein was wrong. There really is a spooky action at a distance underlying quantum theory. And this is one of its more profound and interesting implications. So the interesting thing also about quantum non-locality is it doesn't fall off with distance. It doesn't matter how far apart they are, the connection is just as strong. That's true of telepathy as well. All experimental research and anecdotal research, in that case history research on telepathy, has shown no dependence on distance. Sometimes people say that proves it doesn't exist because everything in nature falls off with distance. Not true. The thing that's most analogous, quantum non-locality, does not fall off with distance. So I think that this kind of connection between bonded members of groups is normal. And because I think it's a normal part of animal behavior, I started investigating it in animals. And the animals I investigated in most were pets, animals we know best, animals that people form bonds with and which form bonds with people, and which people have the best opportunity to observe. We know far more about our pet animals than about any other kind of animal. And yet science on the whole has ignored all the vast riches of data that exist from observations of pets. There's been a kind of taboo against taking pets seriously within science. There's also, of course, a taboo against telepathy and other forms of communication at a distance, other than those allowed by technology or normal physical causes. So this area had been much neglected. When I first started this research in the late 80s, early 90s, the first step was to find out what people had noticed, and I launched appeals for information through newspapers, magazines, TV, radio, and I soon had hundreds, thousands of stories that people sent me about pets coming in. I realized soon that I'd sort of overreached myself. My study was ankle deep in handwritten letters. This was before emails became so common. And I just didn't know how to catalogue this. A friend then advised me about filing systems and how to set up databases, and then someone helped me with computer databases, and that is a brilliant way of dealing with it. I now have all this on a computerized database, FileMaker Pro, and I can now have any number of stories in many different categories, and it's very easy to search the database and build up a kind of natural history. Some people say you shouldn't pay attention to people's stories. Well, why not? Science is meant to be empirical. Empirical means based on experience. And if people tell you about their experience, that surely should be the starting point for science, not something you dismiss. Well, we got it back. In fact, I agree with some of my colleagues who said that the plural of anecdote is data. And if you have lots of stories, they add up to a kind of overall pattern, a natural history. The natural history shows many different forms of behavior that cats, dogs, horses, parrots, and other domestic animals show in response to their owners' intentions. I also have many other unexplained categories of behavior, like animals responding before earthquakes and tsunamis and so forth. But now I'm just going to talk about telepathy. Many cat owners have noticed, for instance, that their cats pick up their intention to take them to the vet. They disappear. And this happens so often that some people desperately try not to give the cat any clues. They don't let it see the carrying basket. They say to themselves, I mustn't think about the vet. I mustn't think about the vet. They still disappear. Some people, in desperation, try ringing the vet from work so the cat can't overhear the conversation. And then they swing by after work to pick up the cat and take it to the vet, and it's not there. We heard so many of these stories that I organised a survey of all 65 veterinary clinics in the North London Yellow Pages, and we asked them if they ever had a problem with people missing appointments with their cat. 64 out of 65 said, yes, it happens all the time. The remaining ones said it happened so often they'd given up the appointment system for cats. People just have to arrive with their animals. The phenomenon that's in fact easiest to study is a very common one, dogs and cats that know when their owners are coming home. Many people have dogs or cats that go and wait by a door or window when a member of the family is on the way home. And if this happens at a routine time, no one thinks it's very odd. It could just be a biological clock. If it happens only a minute or two before, it could be hearing footsteps in the street, the crunch of car wheels on the gravel, that kind of thing. But in many households, it happens 10 minutes, half an hour even in advance. And what's more, it happens when people come home at non-routine times. When I was first launching appeals for this, I ran an appeal in my hometown local newspaper, Newark, Nottinghamshire. And I was talking to the editor of the Newark Advertiser about this, and he said, oh, I think this is completely credible. He said, I notice this all the time. He said, I leave the office at unpredictable hours. He said, but my wife always knows when I've left because the dog goes and starts waiting at the door. And he said, sometimes, he said, it's embarrassing for me because he said, sometimes I decide on the way home to go and visit someone or stop off for a drink. And when I get home, my wife says, where have you been, Roger? You left the office 2 hours ago. So, we found many, many, many cases where this happens. We did random household surveys to find out how frequent. It turns out that about 50% of dogs do it, about 30% of cats. Not necessarily because cats are less sensitive. I think just some of them are less interested. Anyway, I've done hundreds of videotaped experiments on this phenomenon. We videotape the place the dog waits the whole time the person's out. We have them go out at least 5 miles away. We have them come home at randomly chosen times that they don't know in advance. The people at home don't know when they come, and sometimes there is no one at home. The videotapes, which are time-coded, are analysed independently by independent observers to find out